Welcome to another Zincast, and we're going to do something different today. It's going to be more a learning lesson. I'm going to teach you guys some stuff, alright? We're going to do some stuff differently. We're not going to sit here and pick apart. We're going to look at some models. I'm also going to have not a snowfall map, not yet. Just not confident. I don't know how anyone could be confident putting out a snowfall map. I mean, there's confidence in certain areas, but then there's certain areas that, which by the way is like where the concentration of the population is, where, I mean, we're talking about miles here, can make a big difference. But I do want to teach you guys some things. In fact, I'm thinking about making a full-on video about the anatomy of a snowstorm. I think it's very important, so I'm definitely going to work on that when we get into a little bit of a quiet period when we're not expecting snow. Okay, so, and we'll do full production on that, green screen, everything. But let us talk about what's happened. So you may have woken up today, specifically you folks in the New York City area, and see that you're going to be not looking at too much snow, at least according to the models from last night. And yeah, things trended, love that word, trended warmer. But the question is why? And generally, what the consensus is that the storm is a lot less organized than it was previously modeled. And now we're getting better sampling of the storm as it's moving through, right? So because it's over land, so more weather balloons, more data is being put into the weather models. That's why they become more accurate as you get closer to a storm. They don't never become perfect, but they become more accurate. So it looks like the storm being a little bit more disorganized, a little bit more strung out, energy all over the place, not consolidated. What's been happening is you're getting some warm air in because the winds are coming in from the east. And what do we have to the east of us? Fairly warm oceans. Yeah, so when the wind comes from the east directly off the ocean, you have warm air being put into the storm, and that is what's happening. Now, if the storm was stronger and more focused and starts bombing out, which this storm will not be doing until it gets further away, that helps wrap the air around. So instead of it just an easterly flow, you get more of a northeasterly flow, and then you're getting the air from the north coupled with the high pressure to the north, and you can get the cold air. And that's when you say like a storm manufactured its own cold air. But the bottom line is right now the storm is not looking as organized. So at that point you have warm air that wants to sneak in. Now the interior I think is still safe, and by interior I mean Orange County north, Rockland County, that's where I live, by the way. Bergen County in New Jersey, we're going to be on that fun line. So let's actually look at it, because I said this is going to be a lesson, right? So here I got 1, 2, 3, 4, and then a preset map down here. So really 4 layers of the atmosphere. So you guys always like say, oh, I put on the 500 millibar pattern, right? I put on the 850s, right? These are levels in the atmosphere. So 500 millibars refers to 18,000 feet in the air, okay? 700 is about 10,000 feet in the air. 925, 2,500 feet in the air. So I missed 850. I'm sorry, 850, which we always do, is about 5,000 feet in the air. 925 is 2,500. And then you could come down to the surface. Obviously, the surface is the ground that you touch. So that's what I have listed here. So this is the temperature profile for each of those layers. And let me pull this up. To get snow, you need to be below 32 degrees. And again, I'll make a really detailed video on this, but this will be a really quick part. But you have to be below 32 degrees through the entire column, right? From the top of the atmosphere all the way down. Now the surface is actually the only part, like the ground. If you're at, it's depending on how hard it's snowing, the snow can reach the ground even if the surface is above 32, right? That's when the grassy surface, the cold surfaces, you see accumulation, but the roads are like snows forever, but it doesn't really accumulate because it's melting. You get a burst, you might get some accumulation. So that just depends on rates. But that is what's happening. But if you have a warm layer, so that the snow is, it falls as snow always, and then it melts, and then it refreezes. But because, let's say, 700 millibars is warm, now you're dealing with ice pellets, right? Same thing, right? Let's say you were actually cold all the way through, but just 850 was warm. It still is melting, okay? And then rain is, is pretty much melting all the way through, right? It never has a chance to refreeze. So that is why you could also be you could be at 25 degrees outside, 20 degrees outside at the surface, but somehow you have this warm layer somewhere. You're gonna get sleet or grapple. Anyway, I digress on that. But this is what will limit snowfall. Okay, so if you're looking at snow totals or model printouts of snow totals, and you're like, hey, what's going on? Yesterday people were talking 3 to 6, and now it looks like be lucky for 1 to 3. Well, it's because something trended a little warmer. The models are picking up on some warm air coming in. So let's take a look at the atmosphere. Let's just start at 700 millibars. This is 10,000 feet. And let us go through, and you can see this is in Celsius. Okay, so when you see these -7, that's not Fahrenheit. It's in Celsius. Okay, so 0 degrees Celsius is freezing, if anyone needs a reminder. But as we go through here, and this is pretty much the time frame, you can see how this little warm air tries to creep in, okay? But pretty much you're good at 700 millibars, okay, at 10,000 feet. And then look, as the storm moves away and it wraps in some even colder air as it intensifies because the winds are shifting. Okay, well, what does that mean at 850, right? This is about 5,000 feet. Well, take a look. We're not as cold, okay? Yeah, still below freezing. But look what happens here. Saturday evening is what I'm trying to talk about. You see how that warm air is starting to push in, and now you have marginal temperatures, right? And you're above freezing in the 850s down here, and right around New York City as well. Just north, you're cold, and then of course in the upper elevations you've got the cold locked in. Let's see the next panel there. You can see how that warm air really surges by the let's try to circle that. Oops. It's hard to move these without touching any of the other fields there. Okay. See how that warm air really pops around the 850 millibar low? And again, what you're having winds push in like this, okay? But up here, your winds are pushing in like this, okay? So you got cold air damming. That's what they like to call it. You got cold air damming, making the cold air hang in, and along the coast, you have the warm air right off the ocean. And again, you can kind of see how that works out. And then as the storm pulls away, take a look at how the cold air pushes right back down to the coast, okay? And that's when you have these mixing issues, and you have snow to rain, and then ending as a little bit of snow as the storm moves away. But generally, as the storm moves away, you're drying out also. And then look how cold those 850s get. So now let's go ahead and take a look at 925 millibars, which is about, again, 2,500 feet above the surface. So let's go ahead and take a look. So here we are, again, same time frame. And again, you could see even warmer. See that? We're going to switch between 850 and 925, right? So you see where that battleground is, right? I mean, that battleground is like there, somewhere in between there, right? Now, This is the thing that I'm trying to say. And this is why you got to give all the weathermen out there a break when they make their snowfall forecasts and they bust, okay? Because that's like 20 miles. Which means if the storm wobbles, which storms wobble. Just think you're driving your car, sometimes you look down a little bit and you swerve a little bit. Storms do that also. They do not take exact paths, okay? So if the storm wobbles, that warm air, warm tongue that gets in above the atmosphere, right, is going to make a difference. And, someone could be forecasting you for, let's say you live in northern Bergen County, right? And they're forecasting you for 6 to 12 inches, but that warm air just gets in there because the slight shift in the track, and now you're a 3 to 6. It's hard. All right, let's take a look at the surface since we brought that up. And this is also a problem, guys. The surface. You'll notice the surface temperatures are marginal. Okay, look in New York City over here. Okay, we're talking 34, 35 degrees, 33 degrees. So let's just pretend it's cold all the way through and it's snowing all the way through. Unless it's snowing hard, it's going to have a hard time accumulating. This is definitely not going to accumulate on roadways. So then you got to look at grassy surfaces, cold surfaces for accumulation. And by the way, these marginal temperatures do extend north, but like right through here. But the Hudson, when you trace the Hudson, it's warmer by the Hudson because the Hudson River is warmer. So that's why, and this is what you need to look at when you're making snow maps. By the way, all right. So let's go to the surface depiction just to show you. So this is today. You got some snow showers, right? And then we start heading into the weekend. And here comes the storm, okay? And, so these hours jump, right? So we're 66 hours, 72 hours, 78 hours, pretty much jumping every 6 hours, right? But you can see how the storm progresses. And you can see how in the OZ Euro last night, it gets that warm air, and you saw why. Why is it saying it's going to change to rain down here? I circled that horribly. Why does it say it's going to change to rain in New York City? Well, let's go back. What are those temperatures there? 850s, 925. Where you're safe is 700. No worries there. Just look at 850s and 925s, and you can see that. Okay, and then the surface. Look, you're above freezing at the surface. On top of it all. And again, this is even bringing mixing issues all the way into Rockland County, which is why I think that's the points north. I actually texted my buddy George. George, shout out to you. Is that the first time I shouted you out in a video? I don't know. But I texted him yesterday. He lives in Orange. And I said, look, I think you're good. You're good. Unfortunately, down here in Rockland County, points south, that's where you're going to have an issue. Let us take a look at, where is it? Okay, we're gonna look at GFS. This is the 6Z GFS, just to show you some wind profile here. So this is the latest GFS. 12Z has not run yet. I might make a short video if there's any changes in the 12Z. So remember, there could be a slight shift. I mean, just let's look at those thermal profiles one more time. Slight shift in this thermal profile, and all of a sudden you have snow in New York City, more snow in New York City. You're definitely going to be seeing some snow, but right now accumulations seem to be on the light end and on cold surfaces. All right, but let's just take a look at this because this has the wind bars, all right? And you can see, and this is 850 millibars, right? So this is at 5,000 feet. As the low comes around, take a look at those winds, okay? Look at the way they're pointing. They're just jamming in this warm air from the ocean. Okay? So that's important. Yeah, you have this high here that's trying to funnel in the cold air, but this is just overriding. Now, if this storm was stronger, okay, and positioned a little bit more out, you'd have the wraparound coming more like, I have way too much stuff drawn, you can't see anything. Well, I can't see anything. More like that, and then it's not this direct jet fire hose off the ocean. So, I mean, again, these are little things which will affect the forecast. So, I haven't done a snow map yet, but I've been making my thoughts. Okay, so this is a visualization of what I'm thinking currently. All right, so look. Central Jersey, down south, I mean, rain. You might see a flake or two here or there, maybe at the beginning, maybe at the end, but it's rain, okay? Now, that's where we get interesting, when we get into New York City, right? Parts of Long Island. As of now, if you want to take models verbatim, if you want to take the thermal profiles as verbatim, and again, models are getting closer on those thermal profiles. Look, you're going to see some snow, you're going to see rain, and you're going to see maybe some back-end snow again. The problem is your surface temperatures are marginal. There's going to be... You are going to switch over to rain and mix. It's all going to limit accumulation. So, I mean, in this area, I wouldn't say no accumulations, specifically on colder surfaces. You definitely should see some. But it's looking bad for you guys. I'm sorry. I was very optimistic coming into this. Go watch previous videos, but it hasn't been trending our way or your way. So yeah, so little accumulations there. So this is probably going to be like the 1 to 3 range, or the coating to 3 range. Okay. Then you have this little band in here. This is really where that battle zone is. And little wobbles can make a huge difference here. But, and this is what I'm saying, this is so hard to forecast for. I'm thinking, look, you're most likely going to have some mixing issues. Where are those mixing issues going to be? They're probably going to be closer to where these lines change, okay? If you can stay all snow, or mainly snow, you're going to have higher accumulations. I think this range is in the 3 to 6 range. I can see it bump up to 4 to 8. Right? Hell, if somehow this line gets pushed down a little bit, that warm air just cannot get through, right? Then you're talking higher snowfall. Okay? I think anywhere points north of that's why I have orange and so on, is all snow. As the storm exits, as the storm is going this way, it really bombs out, which is why I think this area is going to have like that the heaviest snow, right? If you're looking for jackpot zones. Now, guys, I just want to also point out, I'm on YouTube. Obviously, people are watching. Someone could watch this from California. Okay, you guys could be watching this from Maine. You could live here and be watching it. Okay, I don't know where that is. I know it's New York, but I don't know the county. Okay, but look, I'm generally focused here. Okay, that's generally my focus. All right. A lot of people live here, but I'm just saying. So if I don't fill in maps here, or if I get vague up here, right? Like that's not my forecast zone, all right? But anyway, just want to bring that up. But yeah, so look, besides the jackpot zone, which is out of really my range, I really think that this is not really a 12 plus storm for even these areas in here in the Orange and Dutchess and not Dutchess, Orange and Greene County, Sullivan counties, and so on. Okay, the ski region, Catskill region, Pocono regions. Can you get over 12 with this storm if everything sets up right? There's always the banding. Okay, the mountains squeeze out more. They have better ratios, so I could see it. But I mean, I'm thinking this is probably going to be, like maxed out at 12 in this pink zone. We'll see exactly when I get some more data and I make the final forecast map. These will actually have numbers in it. If you're first time viewing, I'll actually have like 8 to 12 or 8 to 14 in this, and an actual number in here, and so on. But this is my thinking, and this is, I kind of want to bring you in on how I kind of make the snow maps. I kind of start like this, and then I start refining. But, oh, you know, I want to show one more thing, which is actually really cool. Let's go to, this is Tropical Tidbits, great site. Let's go, this is the 6Z GFS surface map also. You can see a little colder than the Euro, but looks very similar, okay? I do want to show you something in here. So this is cool. If you click somewhere, and I'm going to try to click on Rockland County here, okay? This, see if I could make myself a little bit smaller so you can see there you go. All right, so this sounding, this is what it's called. It's called a sounding. Okay, shows you all the layers of the atmosphere and the temperature. You know how I had that kind of layered up in the other thing, and I was going through, and you have to look at colors. But this, you get to very specific points, believe it or not. And the way it works is this zero line, again, Celsius. So here's the freezing mark. It does not go straight up. Okay, this is the zero line right here. Okay, so this is -10. This is 10. Again, they go sideways. Okay, a little bit diagonal. So here are the layers of the atmosphere: 1,000, 900, 800, 700, right? 500. So what did we say? It was 18,000 feet, 10,000 feet, 5,000 feet, 2,500 feet, and then the surface is the very bottom, right? So what it's showing you, the red line is the temperature, and what's showing you is 33 degrees is at the surface, right? Remember I told you the surface temperature is going to be marginal. So you have 33 degrees at the surface, okay? And this is the zero line. And then this is as you go up through the atmosphere. So what you're looking for a snow sounding is your temperature line being below freezing the entire way up. And which it is at this time period, this one specific time period of this sounding. That doesn't mean an hour before it looks like this, okay? It's for this time frame. So let's actually click in here where we have some pink. Okay, it's because this is what the models try to do. This is how they try to also make those the colors on the snow map, okay? But you can kind of see how the thermal profile gets really close here to being above freezing. Let's click on New York City at this time frame, okay? Surface temperature showing 38 degrees, okay? You can see that you are below freezing at 900, right? This is 900 right here. You're below freezing there. But then you jet out over here to above freezing, and then again you go below freezing. So what's happening is it's falling as snow, it's melting, it might be refreezing at this point, so now you're getting sleet, pellets, grapple, but then your surface is at 38 degrees. So even when that falls, again, you're going to see it in the sky, but the accumulating factor on this is negligible, if anything. So that is a sounding chart. That's how it works. It's quite fun to look at, and you can do that specifically when you get to the mesoscale models, which the NAM is still not in range for the NAM and so on. But I mean, we'll look at those also as the storm goes on. So anyway, listen, I hope you guys enjoyed this video. I don't know, I feel like it was long, but I wanted to make something educational. Okay. I feel like the last two videos, I used to go, oh, look at this. Oh, here, look at the red there, right? I feel like that's what we were doing. And I kind of wanted to teach you guys. By the way, here's the GFS clown map. Look at that sharp cutoff. You're talking, and again, do not take this verbatim here, okay? You're talking about, look how much snow is here, and then it's like nothing past that line. It's crazy. But anyway, again, listen, I hope you enjoyed the video. I hope you learned something. Comment below. Let me know. Did you like this? Okay, I'm definitely gonna make a video, like a full production about the anatomy of a snowstorm. That's what I'll title it, and we'll put it in there when I get some time. But listen, everyone, please like, subscribe, hit the notification bell. Okay, we're gonna be doing update. We'll probably do another update later today. Again, if I see changes in the 12Z models, significant changes, little wobbles are just really not worth it. Okay. And then we'll definitely update tomorrow, where we will hopefully be releasing the actual snow map with the actual snow totals. of what we're expecting for the storm. Yeah, so make sure you hit that notification bell. If you don't hit the notification bell, then you're not going to know when I post that video. I'll also be posting maps on social media and so on, so please follow them. They're at Zynlamar, Zynlamar. That's on Instagram, that's on Twitter, X, whatever you want to call it. I also have another one at WeatherScribe, which I'm starting up, again on Instagram and X, Twitter, whatever you want to call it. And of course, on YouTube, we're Channel Zyn. All right, folks, have a good one, and I'll keep you posted.